Last lecture, Newton's law of viscosity was discussed from the subject of fluid mechanics. So you have seen that there you have got one expression for shear stress that was equal to mu into du dy. That means coefficient of viscosity multiplied by velocity gradient, where u was the velocity and y was one direction. The direction of u and direction of y was perpendicular to each other. And one mistake I have committed in the last lecture, that I mentioned that u was supposed to be the function of x and y. No, this is not correct. Actually, it was assumed that u was a function of only y, not x. Okay. If on the x-axis, if you want to draw so many graphs or profiles for the velocity u, all will be parallel to each other when u is a function of only y, not x. And since u is a function of y, in that case only delta u by delta y can be replaced by du dy. Otherwise it is not possible. If u is a function of x and y, in that case that du dy must be replaced by del u del y. That is the partial derivative form. Anyway, it was about the last lecture on fluid mechanics. The topic was Newton's law of viscosity. Now in this lecture, I want to discuss the dependence of viscosity on temperature for liquids and gases. Viscosity, the cause of viscosity is due to two factors, two reasons. The reasons are, one is cohesive force and another one is molecular momentum transfer. Cohesive force means the force of attraction between the like molecules, means similar molecules, like molecules. And you know everything about momentum. So in case of liquids, what happens? The cohesive force is much greater than molecular momentum transfer. That means cohesive force is dominating in case of liquids. So main reason of viscosity for liquid is the presence of cohesive force. And you know that with increase in temperature, cohesive force decreases. With increase in temperature, cohesive force decreases. And if cohesive force decreases, viscosity will decrease. So for liquids with increase in temperature, viscosity decreases. Just opposite to each other. If temperature increases, viscosity decreases for liquids. And for gases, it is just the opposite. With increase in temperature, viscosity also increases. Because in case of gases, the dominating factor is the molecular momentum transfer. For viscosity, the contribution of molecular momentum transfer is much greater than cohesive force. And you know that with increase in temperature, velocity increases. Velocity of the gas molecules increases. If velocity increases, then momentum increases. That means if momentum increases, molecular momentum transfer increases. Okay. If temperature increases, velocity increases. If velocity increases, momentum increases. If momentum increases, then momentum transfer, molecular momentum transfer increases. And it is the cause of viscosity of gases. That means viscosity increases. So for gases with increase in temperature, viscosity increases. So this was a discussion on dependence of viscosity on temperature. If in a given problem nothing is mentioned about the relationship between viscosity and temperature, in that case you will simply assume that viscosity remains constant during the course of the flow. In case of gases, when there is large fluctuation in the temperature, if the fluctuation is large, in that case, to get the accuracy of the result, you must include in your calculation a relationship between the viscosity and temperature. If the fluctuation in temperature is high, and if fluctuation is there, but it is very low, the level of fluctuation is very low, in that case, you can assume the viscosity to remain constant during the course of the flow. Okay. And for liquids also same thing. For liquids, it is also same thing. If nothing is mentioned, you simply assume that viscosity remains constant. But you should know that if it is required, then you have to take care of the dependence of viscosity on temperature. Okay. Thank you. It was all about dependence of viscosity on temperature. Thank you once again.